Hello and welcome to today's class. In this particular class, we are going to handle quadratic expressions and equations. All right. so, this is a continuance of the algebra series that I've been doing. Now, quadratic expressions and equations are very, very easy to understand. So, I want you to just kind of follow my lead and as I introduce you to this world of algebraic expressions called quadratic expressions. So whenever you have an equation, all right, whenever you have an equation where the highest power of the variable is 2, okay, so we're looking at the highest power being equal to 2, where the highest power of the variable is equal to 2, then that equation qualifies to be called a quadratic equation. All right. So whenever you have any algebraic expression in which the variable has the highest power of 2, then we say that that is a quadratic expression. Maybe if I just give you a general format of what quadratic equation would mostly look like. So usually they are in the form ax squared plus bx plus c. Yeah. So this is how a quadratic expression would look like. And in this particular case, a, b, and c are usually coefficients. Okay, so a coefficient basically is a set of numbers belonging to, maybe decimals. They can be fractions. They could be whole numbers. They could be integers. Those are actually coefficients. So any number that comes before a variable is usually what we call a coefficient. So in this particular case, all right, that is ax squared plus bx plus c, which is the general form of a quadratic expression. A would be a number or even a fraction or even a decimal, same to B and C. Let me maybe give you an example of a quadratic expression from here that will make sense. Let me just kind of state it out. So an example of a quadratic expression would be, let's say, if I took x squared plus 2x plus 3. Okay, so x squared plus 2x plus 3. So in this particular case, this here would be called a quadratic expression. Okay, a quadratic expression. And why is that so? Okay, why is that so? Because first of all, it's following the general format. All right, it's following the general format of what we know to be a quadratic expression. Okay, and that is ax squared plus bx plus c. All right, so you see that we're having our x squared here. And remember, when we're defining a quadratic expression, I told you that it is any form of algebraic expression where the variable has the highest power of 2. So you notice that x is raised to the power of 2. All right, so it's we already have that working in favor of this particular expression here. And then other than that, it takes the general format, that is ax squared plus bx plus c, where a is a coefficient, b is a coefficient, same to c. So the coefficient in this particular expression will be 1 for a. So a here will be 1. All right, b will be 2, and c will be 3. So those are the coefficient. Of course, the variable in this particular case is just x squared and x. Okay, so the coefficient there would be 1, okay, 2 for the coefficient just next to x, and 3, which is a constant standing on its own. So usually quadratic expressions are used to describe curves. Okay, they're usually used to describe curves, but we are not looking at that today. We're basically trying to look at what they are and how they look like. So another example I can give of a quadratic expression again, so that to make it easy for you to understand, would be, let's say I take 3x squared plus 4x plus 5. All right. So this here also qualifies to be what? A quadratic expression. Why? It has taken the general formula of a quadratic expression, which is ax squared plus bx plus c. That is 1. All right. So it has taken that particular format. Then other than that, we have a, b, and c being represented as coefficients. All right. So in this particular case, our a, the value of a will be 3. The value of b will be 4, and the value of c will be 5. Now I want to give a note. Okay, I want to give a very important note as I move before I move on to the next thing. So I want to give a particular note that a must never be equal to 0. Right? For it to qualify to be a quadratic expression, a must never be equal to 0. So that is the coefficient just before x squared. So yeah, it must never be 0. All right, so I want to go ahead and show you how we can actually obtain quadratic expressions using linear equations. Okay, right, so awesome. So this is going to be a quick demonstration of how you can actually derive a quadratic expression using first degree linear equations. Okay, so this process of derivation of quadratic expression using linear equations is usually what we call expansion. Okay, we already did expansion when we were looking at the big expression, and so it's we didn't look at it really into details. We looked at it in part. So in this particular class, we're just gonna go and maybe delve in a little deeper into how to expand two first degree linear equations. All right. So basically, we know what expansion is. Expansion is the removal of brackets, okay, of removal of brackets in a quadratic expansion, in a quadratic, in an algebraic expression, sorry. Anytime we're trying to remove brackets in an algebraic expression, then we call that process expansion, all right? So that's what we're having there. But you see, we also notice that by expanding linear equations or first degree linear equations, we always end up having quadratic expressions in the process. And so we're going to handle this example here. So we're going to expand m plus 2n and m minus n. All right, so these two are first degree linear equations, and so by expanding them, we are expecting to find or to derive a quadratic expression. Okay, now first rule: when you're expanding any format of first degree linear equation, you always want to break one bracket and maintain the other. Okay, you want to break one bracket and maintain the other. So if you choose to break the first bracket, then that is what you'll work with. Okay, then you'll have to maintain m minus n. If you choose to break this other one, then you'll have to maintain this other one. But in this particular case, because I just want it easy, I'm going to break the one on the left, and that's what I'll be doing for the rest of the problems that involves expansion. I'll always be breaking the one that is in the left. So in this particular case, to break this, I'll have m, which is in the first bracket, into multiplying the bracket, the term that we are actually not going to touch in this particular case. Okay, so that's going multiplying m minus n. All right, then plus 2n. Remember, the plus 2n is coming from this bracket, that this particular linear term that we are actually breaking here. So plus 2n into, we are maintaining m minus n. So the rule is break one, maintain one. So we are breaking the one on the left and we're maintaining the one on the right. And so you'll notice that we have m into m minus n. So we have maintained m minus n. We have 2n, maintaining m minus n again. And so what we've broken is the first, linear, first degree linear expression here. And so we've broken it. And so we're having this m multiplying the first m minus n, and then we're having 2n multiplying the second one there. So arranged in this format, it then becomes easy to expand. Okay, so basically it will be m multiplying m. All right, m multiplying m will give us m squared. So the powers of m will be added to each other. So it will be m raised to 1 plus m raised to 1. Of course, that is 1 plus 1 giving us 2. All right, so that's going to be m squared. That's okay. That's going to be m squared. And then m multiplying negative n. M multiplying negative n. So that's going to be minus mn. All right, minus mn. So we are done with we've expanded the first bracket, and now we go to the second bracket. So it's going to be 2n times n. 2n times n. And so that's going to be plus 2mn. All right, that's going to be plus 2mn. That's going to be plus 2mn. Then it's going to be 2n times negative, and it's a positive number times a negative number. And so that's going to give us a negative. And so it's 2n squared. Okay, it's n times n. Basically, that means that we're going to have to, the powers and then. All right, so I wanted to notice that we're having m squared minus mn plus 2mn minus 2n squared, which then in this particular case has to be simplified. Notice that mn and mn here are like terms. Okay, mn and mn there are like terms. So the coefficient here is -1 and here it's 2. So basically it's like having -1 plus 2. Right. So when you simplify this particularly, we're going to have m squared. So negative mn plus positive n, which is the same as -1 plus 2, will be plus mn, okay? Minus 2n squared. So this will be the solution to this particular problem. And note that what we are having here is an algebraic, it's not a what we're having here is a quadratic expression. Yeah, what we're having here as our final solution is a quadratic expression, which we've obtained by expanding two linear equations. Okay, all right. So why is it quadratic? The highest power of the variable is actually 2. M highest power is 2, and you can in this particular case we also have n raised to 2. So the highest power of these variables is 2, so that already qualifies it. And plus and that already qualifies it. So basically we'll just kind of leave it at that. I don't want to go to the general format at the moment. Why don't we handle another example and then see what we get as our quadratic expression from expanding two linear equations. Yes. So on to our last example, so that we end this particular class. We are going to try and expand these first degree linear expressions that we're having here. Of course, we are doing this with an attempt to try and derive a quadratic expression. Remember, a quadratic expression should take the format ax squared plus bx plus c. And we are saying that in this particular case, a must not be equal to 0 and a, b, c should be coefficients. So this is the format that we expect our answer to basically be in as soon as we're done expanding these these two linear terms here. All right, so we are having x, okay, we're having x plus 5 into 3x plus 2. All right. And so remember the rule, the golden rule here is that you break one, you maintain one. So we're going to break the term on the left and maintain the one on the right. Okay. It's easier working, approaching it that way always. So we're going to have x, that is the x that is in the left term here. Okay. Just a minute. Yes. So we're going to have x from the first bracket here on the left, and we're going to maintain the other one. Okay, so it's going to be x into 3x plus 2. All right, plus 5 into 3x plus 2. So note we have broken the terms that were within the first or we're in the first linear expression. All right, so we have our x here, and we have our 5 on the other end, and then we've maintained this particular bracket there. So it's 3x plus 2 plus 2, 3x plus 2, all along, yeah, all across the board. Right, so after we have this equation in this format, it then becomes easy to solve it. Yeah, it becomes easy solving this, because basically what this means now is that we're going to multiply each term by x. All right, so that's going to be x times 3x. Okay, so x times 3x will give us 3x squared. X times x. Yeah, I think that should be sorted by now. And then we're going to have x times 2. All right, x times 2 there will give us 2x. All right, that's pretty basic. And then we're going to have 5 times 3x. 5 times 3x will give us positive 15x. And 5 times 2 basically will give us 10. All right, now looking at the equation that we have here, we can see that we have like terms here. We have 2x and we have 15x here. So we can simplify that by adding those two. And so when you add those two, we're going to have 3x squared. So 2x plus 15x will give us 17x plus 10, and that will be the solution to this particular problem. I want you to note that it has actually taken the general form of a quadratic expression, that is ax squared plus bx plus c. So in this particular case, our a is, this just a side note, our a is 3, our b is actually 17, and our c is 10, of course. Yeah, you see that, you can see that based on the general format of a quadratic expression. So that's it for this particular class, and see you in the next one. Thank you.